Out in the cold, silent expanse where the sun is just another star, a human-made object continues its lonely journey. It has traveled farther and longer than any other emissary from Earth. This is the story of Voyager, a testament to our relentless curiosity. For nearly half a century, these twin spacecraft have been our eyes and ears in the outer solar system and beyond. They have sailed on a sea of interstellar plasma, carrying a message from their creators. Now, from the edge of our sun's influence, one of them has sent its final, faint whisper back to us. A message that took decades to travel and required unprecedented ingenuity to decipher. The Voyager spacecraft are currently over 15 billion miles from home. At this distance, the sun's light takes more than 22 hours to reach them. The signals they send back embark on an equally long journey home. This final message was an unexpected, faint, and distorted signal captured by NASA's Deep Space Network. Scientists and engineers worked tirelessly to pull a coherent message from the cosmic noise. This final transmission is a profound reminder of what we can achieve when we dare to journey among the stars. The Voyager missions were the result of a rare cosmic alignment and human foresight. In the late 1960s, a graduate student at JPL discovered that the outer planets would soon align, allowing a single spacecraft to slingshot from one to the next. NASA seized this opportunity, designing Voyager 1 and 2, launched just weeks apart in 1977, to conduct the first close-up studies of the gas giants. Voyager 2 visited all 4 planets. Voyager 1 took a faster path toward interstellar space. Each carried a suite of instruments to study planetary atmospheres, magnetic fields, moons, and rings. To power them, each Voyager used a radioisotope thermoelectric generator, converting plutonium's heat into electricity. Affixed to each was the Golden Record, a time capsule curated by Carl Sagan, containing images, sounds, music, and greetings in 55 languages. It's a greeting card from Earth, sent on an interstellar voyage of billions of years. Voyager is both a scientific mission and a message in a bottle to the cosmos. Communicating with Voyager is an exercise in cosmic patience and precision. As of August 2025, Voyager 1 is over 15 billion miles from Earth. Light takes more than 22 hours to reach it. The Deep Space Network, with massive antennas in California, Madrid, and Canberra, is our link to these distant explorers. These antennas are sensitive enough to detect signals billions of times weaker than a refrigerator light bulb. Voyager's transmitter is just 23 watts. By the time its signal reaches Earth, it's measured in quintillionths of a watt. The Deep Space Network uses state-of-the-art receivers and powerful computers to reconstruct the original message. Sending a command requires accounting for Earth's rotation, orbit, and the spacecraft's trajectory. It's like throwing a football to a moving receiver miles away, leading the throw by nearly a day. That we can still talk to these 1970s-era machines across such a gulf is a quiet triumph of science. Voyager's voice is faint, but it still reaches us from the edge of the sun's domain. The final message began as a faint, irregular signal detected by the Deep Space Network's Canberra station. For weeks, it was barely distinguishable from cosmic background noise, a ghost in the data. The signal was traced to Voyager 1, its power far below anything previously received. The data stream was corrupted and fragmented, as if the spacecraft was speaking in a broken language. The engineering telemetry was unreadable, a stream of ones and zeros that made no sense. The team at JPL knew the spacecraft was still transmitting, but they couldn't understand its message. It was a frustrating situation. Humanity's farthest emissary was calling home, and we couldn't decipher its words. The signal was fundamentally different from decades of standard data, suggesting a deep-level fault in the onboard computer. The team had to devise a new strategy, not just to amplify the signal, but to reverse engineer the problem from 15 billion miles away. It became a cosmic detective story, with Voyager's final scientific contribution hanging in the balance. The faint echo from the void was a puzzle of the highest order. The race was on to decode Voyager's last whisper. Voyager, one's final transmission, was a multi-layered puzzle. The signal's weakness suggested a major power degradation on board. Every bit of data was precious, painstakingly collected and preserved. The data itself was corrupted, a jumbled mess, as if the onboard computer was pulling random words from different books. The JPL team suspected a memory failure in the flight data system, likely caused by decades of cosmic ray exposure. A single flipped bit in the FDS's core software could explain the systematic corruption. The challenge: identify the altered bit without direct access to the system. Using original schematics and source code, the team ran simulations, flipping single bits to reproduce the garbled output. It was digital archaeology, searching for a tiny error in a 1970s machine now sailing between the stars. The solution would require both ingenuity and patience. The breakthrough came from painstaking collaboration and innovation. Engineers used arraying, linking multiple deep space network antennas, to boost the signal-to-noise ratio and pull Voyager's message from the static. The software team narrowed the likely corrupted bit to a section responsible for data pointers. A single flipped bit had caused the FDS to misread data locations, transmitting a segment of memory repeatedly. The team crafted a special command to bypass the corrupted pointer, a risky maneuver that could silence the spacecraft forever. The command was transmitted, and the team waited 45 hours for a response. The reply was a moment of triumph. The new data stream was coherent and structured. Readable engineering data confirmed the spacecraft's health. The team had diagnosed and bypassed a fault in a 1970s computer from 15 billion miles away. It was an unprecedented feat of remote diagnostics. With a clear channel re-established, they could finally download Voyager's last science data. The last whisper was finally heard. With communication restored, scientists analyzed the data Voyager 1 had tried to send. The plasma wave system recorded a sudden, sharp spike in plasma density, 10 times higher than any previous measurement. Voyager had flown through a dense, compact cloud of interstellar material, the first direct observation of such a feature. This discovery revealed the interstellar medium is far more complex and structured than previously thought. The dense cloud could be a supernova remnant, or a knot in the local magnetic field. The data also solved the mystery of the signal corruption. Intense cosmic rays in the cloud likely flipped the critical bit in the FDS memory. Voyager was not just an observer, but a participant in the dynamic environment it explored. Its final message was a story of that dramatic encounter. Voyager's legacy is etched across the history of planetary science. Before Voyager, the outer planets were fuzzy blobs. Voyager gave us breathtaking portraits and revealed active volcanoes, intricate rings, and new moons. Voyager 2 gave us our only close-up views of Uranus and Neptune, rewriting textbooks on these distant worlds. The Voyagers turned points of light into vibrant, complex places, expanding our conception of the solar system. They measured the heliosphere and became the first human-made objects to enter interstellar space. They confirmed our solar system is intimately connected to the galaxy, constantly interacting with the interstellar medium. As Voyager 1 falls silent, its legacy is cemented, not just as data, but as a symbol of human ambition. It represents a journey of 15 billion miles, powered by 1970s technology and generations of dedication. The Voyager spacecraft are our silent sentinels, carrying the golden record and the story of humanity into the Milky Way. They will wander the galaxy for eons, a testament to our desire to explore. The decoding of Voyager 1's last whisper marks the end of an era, but not the end of the story. The data from this final message gives us a glimpse into the complex structure of our interstellar neighborhood. It provides a target for future missions, turning theory into a destination. The silence of Voyager 1 is an invitation. Its final transmission will inform the design of future interstellar probes. Scientists are already conceptualizing faster missions, equipped with more sensitive instruments to map the interstellar medium. Voyager's journey stands as a monument to the power of curiosity-driven science. Investing in our curiosity is investing in our future. The final message from Voyager 1 is not a goodbye, but a signpost pointing the way forward. The question is not what else is out there, but whether we will continue to listen and dare to journey even farther into the stars.